Hi guys, and welcome back to Ades Workshop. Now this is going to be part 3 of the ball turning attachment. Now in part 1 and 2 you'll have seen me make the base plate and the lower bearing holder. So in this part 3 we're going to make what I previously called the swivelly bit. Let's call it the rotating tool holder. Okay, now little concern I have is that I want the finished product to be able to turn a ball with a diameter of 30 millimeters. I won't need to go much bigger than that, or any bigger than that really, but what I have to be very careful of is how it all stacks up height wise to allow the turning tool to have enough clearance to be able to turn a ball with a radius of 15 mil. So I've actually, unusually for me, done a little bit of forward planning, and I have a drawing. I'll bring you in on the drawing. Okay, so it's a little better than my usual standard of drawing. I've actually, I had something to do yesterday evening. I thought, well, I better sketch this up. So I sketched it up on a bit of graph paper. So we've got a diameter here which is going to fit inside the bearing. Small step, 0.25, which is to clear the outer race. So yeah, that's what the little step is for. And I've actually put a lip on the outside, which is going to come down over the top. Oops, banging the camera. It'll come down over the top of the outside of here, and that'll stop the ingress of any swarf into the ball race. Okay. Now, I've gone for a diameter of 60 mil. Eventually, it'll have a 10 mil slot. There's going to be a tapped hole up from the bottom. There's going to be tapped holes from the side to hold the turning tool, that sort of thing. But that is a basic drawing, and that will allow me to actually, well, maximum theoretical will be 30.5 diameter, so I've kept all the heights quite low. And another good use for this lip here is that it adds a bit of strength into the lower part, because that thickness there from that shoulder to there is only 5 millimeters. And obviously if I'm pushing on a screw on the slot against a tool, there might be a bit of a tendency for it to gape in the slot, as it were. Might have a bit of flex in it. So this lower ring or skirt that's going to be on it is going to add a little bit of strength, as well as keeping the swarf out from the bearings, which are going to sit in here. So I've got my lump of metal up in the lathe. Let's get on with it. Oh, we'll have to hold off for a minute. A parcel has arrived. Now, I was expecting this parcel, but I didn't expect it to come quite so quickly. And it's from a fellow YouTuber. I will put a link below, but it's from Everett at Everett's Workshop. And he very kindly has sent me some cobalt drill bits, imperial sizes. And I've got very few imperial size drills nowadays, let alone cobalt drills. So, totally at his own expense, he sent me these drill bits which he had surplus. So, thank you very much, Everett. I'll be opening the box in a moment. Also, in the box, I believe, are going to be some of his stickers, and I've reciprocated and sent him some of mine as well. And these are going to be the first stickers that I've got from another YouTuber, so I'm quite excited about that as well. So let's go ahead and open the box. So I've just opened the box up, and it contains 3 smaller boxes, and oh great, some stickers, YouTube stickers. Those ones have picked up a little bit of the blue off there. But yeah, it's Everett's Workshop, and I strongly recommend you go and have a look. And he's at, obviously, Everett's Workshop on YouTube, and I will put a link below. So let's have a look what we've got. Oh my goodness. Well, quite a nice assortment of cobalt drills there. Wow. And these are imperial sizes. That's a quarter. I'd imagine somewhere around 3/16 looking at it. Yeah, 3/16. Let's say we got an 1/8 there. Yep, just to make out an 1/8. Another quarter one by the look of it. And oh, some nice stubby ones as well. That's brilliant. 1732. Oh, can't quite make that one out. I'd say that's looks 7/16, something like that. 1732. Oh, these are amazing, Everett. Thank you so much. Oh, and even more. Yeah, more small drills. Oh, wow. Appear to be brand new, these ones. Yep. Look at this. And say that's 1/2 inch plus, that one. 5/8. Oh, that's a sweet looking drill. Yeah, brand spanking new. Everett, what can I say? I'm astonished at your generosity. This is fantastic. Because I've got very few Imperial drills. And again, 5.8 brand spanking new in the packet. Everett, thank you very much indeed. Alright. So back to the matter in hand. I've got a piece of 3-inch. It's EN3B this. It's nothing spectacular. And I got a 2-inch wide piece of it. Now, this is going to be a finished largest diameter of 60mm. So I think what I'll do, I'm going to rough all this out and leave all the dimensions of mill up. You know, while it's warm and whatever, because it's gonna, you know, I'm going to be hacking away at this. And my overall length at the end, let's have a quick look, 18.5, 19, 20, 21.5 and 8, 29.5. It's going to be about 30mm. So yeah, I've got like 50mm there at the moment, so it's going to be 20mm off the end. Had I pre-planned it, I could have ordered a slightly smaller piece, but never mind. It's inside there the bit I want. At least if it was if I'd ordered a smaller one, I couldn't put material back on, as it were. So, don't know what this is going to be a machine like. I'm not going to go mad at it. Again, I'm using my tips that are ground carbide tips for aluminium. Let's just take it gently on them. Let's just do a touch off. Whoops. So I'll throw my spanner and then I'll lock the carriage. So, hey. Carriage lock. Let's have a crack at this. See what it machines like. I'm doing 535 RPM and I'm just tickling it across the surface. Let's have a look. I know it hasn't cleaned up yet, but that seems to machine quite nicely. Right, carry on. So I'll probably show you this in real time, but all I'm going to do at this stage is face this side off, and then I'm going to turn the OD to 61 diameter, mill over size of my sort of nominal finish size. Going a bit slow down there, let's just take it gently. Okay. Yeah, turn the OD to 61 diameter over a length of, well, the major diameter runs over a length of 21.5mm, so over about 23mm back, something like that. I'll just put another cut on. Oh, to have a machine with the power feed on the cross slide, eh? Yeah. Not very often I'm turning diameters or facing this big. I'm getting a few marks in there. And what I'll do is speed up my RPM as I come towards the centre to keep the surface speed up. Try and avoid chipping my tip. Okay, well that's actually cleaned up there. Let's have a look at that surface finish. No, the material seems to be cutting freely enough. But it does have a few little marks on the rings there. I think what I'll do, I'll put a bit of my cutting compound of choice on there. Cutting fluid. I just use a bottle of this Molly Slip MWF, whatever. That's, you know, that's what I could get hold of at the time, you know, in small quantities. Yeah, you can buy all sorts of cutting fluids at a gallon a time, but I mean, I've had this bottle 12 months or so, and it's probably 3/4 full. You know, you can imagine a gallon of it. Well, it would outlive me. So I'll take a couple of thou there. I'm going to try about 800 RPM and try and get a bit more consistency of feed. Hand feeding very slowly, it's hard to keep it consistent, whereas when I'm going at this sort of speed I seem to be a lot more consistent by hand. Here we are, let's bring that cutter away. That's better. Yeah. We live with that. Okay, so that's it faced off. Just swing the tool back to normal operating position, square on. Do a touch off. Again, let's experiment slowly. Maybe 500 RPM. Gotta use the power feed. Give myself a 0 here. Whoop. That's the base. There, I got a couple of zeros. I want a distance of 21.5 minimum, so I'll probably go about 25 mil. I'll turn back and then I'll be holding it on that bit afterwards. I just as well keep going actually, save a bit, because I'm going to be taking a fair bit off this. That'll do. Let's have a look at my finish. But we're not cleaned up yet, so I'm not getting a true representation. Let's take about 0.15 aside. Let's see if it can cope. Here we go. It's a bit stringy. I don't like this stringy stuff. So I found something that works. I'm running at 490, but it drops to about 460 on the load. And I'm taking 0.25 mil on the crack. Still on a 0.125 feed rate. And the swap is breaking nicely now. You watch, it won't this time. Yeah, chipping off in small chips. Not filling my bed with big stringy bits. And yeah, I know I'm only taking half mil a pass, but it is only a small lathe. But I've gone back to the standard carbide tool rather than the ground ones for aluminium. So this is the standard carbide tool, and I've gone with a 60-degree approach angle with the triangle pointing straight in, as you can see. So I've upped the speed, kept the cut and the feed the same, but upped the speed a bit. I've got a 0.25 cut. Now I'm getting a really good finish with a bit more load. Now, you can probably hear what you might have done if I wasn't talking over it. When the cut came into play, the lathe did slow down a touch, but it's holding 580 RPM during the cut. And it's given me quite a spectacular finish on the outside. I mean, carbide does like to work. The only problem is I haven't got the machine to work it. We should be pretty close now. I'm just going to take a spring cut. Yeah, there was a bit of spring. It's cutting again. Just give myself a 0 there so I can I know where I was. And I think that should give me about 61 mil. 61.04. That's absolutely fine. There's a mil to come off that at a later date anyway. Is it warm? Yes, it is a bit warm. I bet I'll lose that tooth though when it cools down. So I've got roughly 20 mil to come off the overall length, so this is going to take some time. 0.25 at a time. I'm just whacking it down to about halfway for now, and then I'll might even drill a hole up the centre. Just trying to speed up the metal removal. Well, I've probably been at this for about 40 minutes now. I've got 0.2 left to come off. And that will leave the overall thickness a mill up. So yeah, maybe, you know, but it's roughing out, as I said, and this was very much roughing out. It was 20 mil to come off there, just over 20 mil, and obviously it's this is the smaller diameter now, is 61, so it was 10 mil bigger. I got the tool right back against the right back into the tool holder, so I'm afraid you can't see the cutting tool. But yeah, the final point 2, probably 40 minutes on that. I cleaned the bed of the lathe out twice. But yeah, let's just take it to my reading. There we go. That should do me. These little tiny cuts I'm just finishing off with are a bit stringy. I'm adjusting the speed up as I go in to try and keep the surface speed somewhere near where it should be. And hopefully, with the finished size being 29.5, that should measure 30.49. Happy days, that's a mil over. Right, so the next step is going to be shoulder on here, down to 16 diameter and back 8 mil. So, square the tool up. I'll loosen up my carriage, give myself a 0. In fact, my stop's in the way. What I'll do is set my stop back. There's the 0. If I set my stop back 7.9, now 8 mil is the actual dimension it'll end up from the finished size back from this face. So if I do it 8 mil, it will still leave, because there's a mil on here, it'll leave a mil on the back face as well. So yep, so check my stop, 8.05. Okay, so I'm going to start machining down again, much more of the same, until I get to, well, my finish down to 15, so until I get to 16 mil. I'm just going to start skimming across the top. Bit stringy, so another 0.15 aside should bring that stub down to 16 diameter there. Up to the shoulder at 8 mil. Oh, just below, not to worry. Okay, so hopefully that is around the 16 mil mark, which is a mil over size. Actually 16.15. Take another 0.05 aside. Just to get it somewhere near. I think my tip, listening to it, is shot. That's probably why I lost a bit. 16.15, yeah, I didn't take anything off there. I think I've lost the tip. Anyway, right, so we are now roughed out. So I need to dig into this space 3 mil at that 16 diameter, 3 mil deep, and come out to a diameter of, and I did decide on a diameter, oh yes, it's going to be a diameter that clears just this OD. I'll measure up what this OD was. I think it was 56 mil. So I'm going to do it at 56 mil temporarily. So dig into that face at 16 diameter, 3 millimeters deep, and come out to a diameter of 56 mil. So I think I'll get a little V-tool and dig in 3 mil first, and then we'll face it in and face it out to the diameters. So it's a bit difficult to explain how I'm doing this, but I put my boring bar in on a sort of 45 and dug in, sort of, imagine backwards, on an angle this way, until I got to like 2.5 mil deep. Then I've come out somewhere near, gone in somewhere near, then squared up on the flat surface with the boring bar and bored the OD into sort of, well, in fact it's about 2.9 deep, bored the OD to the diameter of 53, which is a mil under size. So now I've got the outside to size and I'm 2.9 deep. Well, in fact I went 3 mil deep. I've now got this bit in the middle to square up to get out of the way. So I should be able to get in there with a regular turning tool now and just skim that back face flush with what I've just done to that diameter of 16. So that'll be my next step. Well, as it happens, I can get in there. Okay, so as we stand at the moment, it's all roughed out, other than the little 0.25 undercut to relieve the outer race. And everything is a mil oversize. So my plan being now is I'm probably going to hold it on that spigot. I'm going to turn 0.5 mil off that, turn it round, take 0.5 mil off that back face, take this diameter down to size, then turn it round, back as it is now, so I know that top face is finished machined, the OD is finished machined, and then finish all these dimensions to size. So yeah, turn it around in the chuck, and I'm going to skim 0.5 of this space, because my overall length is 1 millimeter oversize. That'll be 0.5 mil off this space, and 0.5 mil off all the faces on the other side to bring them all into size. So I finished the OD and I faced that. Next step is turn it round. However, I think what I'll do is put myself a little centre drill in here, and that will allow me at a later stage to be able to pick up the centre for when I come to put a slot on. So I think I'll just put a centre drilled hole in that face before I turn it round. Now I know it all looks nice and shiny, and I won't pretend I haven't polished it. I did hit it with a bit of 400 wet and dry just to remove some of the machining marks, if nothing else. So yeah, we all cheat, we all cheat. So we've turned it round, or I've turned it round. I've just put a clock on it and it's running lovely on the OD here, and the back face looks good. All this is going to be machined anyway, so yeah, I'm happy with where I am. So I've just done a quick measure, and it was showing 0.45 to come off this space. So I'll just give myself a 0. Give that a touch off. Have another measure. Ooh, 21.87. So that's 0.35 to come off that face now. I'll take 0.15. And another 0.1, 0.2, it's actually showing 0.27. Let's have a measure at that. Set it back to 0. $21.50. We'll go with that. We'll keep that. Right. We'll call that 00. So while I've got a good datum, I'm going to face the bottom of this off. to size, and the step should be 8mm. So from my 0, I need to face that at +8. That should just, not quite, now it's touching. 0.4 to come off there. Speed proceedings up a bit. I'll pretty much stop now when I get to 8mm. My wife's just come home from work. I'm giving her the thumbs up out the window. So it's 8.1. And a little bit faster. Running at 1050 RPM here. Okay, so that's those two faces done. I'm going to have to cant the tool round now to do the diameter and the first part of the bore before I put the boring bar back up. I've just looked back over some of the footage and I wasn't very clear about how I went about doing the undercut in here, so I'll show you when I do the finishing. So just bring the tool forward to touch the very end and set a 0 on my DRO. The tool is set just off square, so I will be able to machine in both directions with the tool. So I've blacked it all up so you can see what I'm machining. So this at the moment is around the 16mm mark. So I'm just going to touch and give myself a 0. There we go. Now my overall depth, so I'm going in, my overall depth from that front face to the back is going to be 11mm. And that's 10.7. So I'll just wind out across the back face. Until I get to a point where the tool is about to foul on the outer lip. I've got a little bit of clearance there, just come in a bit. Just dig in gently, and I'll go back across that face to my 0. Until I get to 0 on my DRO. I'm going to machine the 15mm last, because that's the only important. That's 10.95. Again, I'll come out as far as I dare. You can't see now because I got a bit of swamp in the way, but you get the picture. I'll come out as far as I dare. I've got a little bit to go yet. I'm just going to stop that and move that bit of swamp because I can't see. Come on, out you come. And it's so fine, this swamp, I'm only taking tiny bits. Come on. Right. So, where am I? I can go a little further. I'm watching the bottom of the tool. About there. About the 8mm mark on my DRO. So I'm just going to go in now, the final. There, that's 11mm on my DRO. And back in. To my 0. So I'm going to take a little cut off this diameter, maybe 0.1 aside, just to see an actual figure where I am. Here we go, this is cleaning up now. I'm running about 750 RPM, I could be going a lot faster than that, but I seem to be getting a lovely finish at this speed, so I'll stick with it. And again, I'll go in till I get to the 11 mark, which is the depth I've just machined. There. So I'll just take a quick measurement of that to see where I actually am. Yeah, I'm on 16 mil, we'll call it. Okay, so at a point 22 mil out, I want to undercut. So 16 to 22 is about 6 mil, so that's 3 mil aside. I'll just set a 0 on my DRO, we'll wind out 3 mil. There, and I'm going to set a 0 again. Now from a point, I don't know, let me just flick my monitor around. From a point where I am now to the outside lip, I want an undercut at 0.25 millimeters. So I'm going to set up what I can get to of that bit now. So that's going to be on a reading to 11.25 now. And I've hit it. I can't come too far out. That's about it. Okay. So at this point, I need to change my tool, or the angle of my tool, touch off on what I've just done, which is a clearance, so it's not important, and bring it out somewhere near the outside. So I'll just revolve my tool around, which allows me to come further out. And I'm going to just touch there and keep coming out. Well, I would if I could see what I was doing. Swarf's building up again. I'm just coming out further. I think you can see it on the colour of what I'm doing. You can't see the tool itself. And at a point about there, about 10.5, I'm getting a bit close. So I'm going to keep getting in there, come out to 10.5. And that will allow more room for the boring bar to do the outside. Again, I'll just have to switch that off and clear the swarf. Now I'm going to slowly, there we go, come in to touch that undercut there. And wind that out to the point I can't go any further. So let me just get the tool out of the way and I can explain what I've done. So I haven't finished the inside of diameter, it's still at 16. The depth of the first part of the undercut here is correct at 11 mil from that face, and this further bit that's cleaned up, that I've removed the pen from, is at 11.25, out as far as I can get it with this tool. So I'm going to change to the boring bar now. I don't know if I'll get the boring bar in there square. Maybe if I use the 10 mil boring bar, we'll have a look. And face this out to the corner of what I've got here at the moment. And then I'm going to use the boring bar and gradually increase that diameter until I've got a working clearance on the outside of the ring. And it should be about a mil in there. Well, it's a mil below the nominal of that without clearance, so we'll see how we go. So yeah, so I've just been boring out on the outside, and I've got to a point where the aluminium ring just fits in. There isn't, well, if there's half a, probably a thou, probably 0.025 millimeters in there of clearance. I think I need a bit more than that, so I'm going to take a further 0.1 per side. So I'll just take a scratch pass along that diameter. It's around the 16 mark at the moment. I set a 0 on my tool at the end, so I know I've got to go into 11 millimeters deep. I think I'll speed things up a bit in a second. Okay, so I'll just get a quick reading off there. I'll probably leave it about 0.2 up, and then we'll start measuring with a mic. 15.9. So 0.35 aside off it. I'll do 0.1 aside at a time. Yeah, go a bit quicker, I think. Running at about 800 RPM. This will be 0.2 aside off. Should end up at about 15.2. And I'll swap to a mic. Bit faster, I think. Oh, that improves the finish. Running at 900 now. Okay. See what it comes out at on the calipers. Yeah, a bit smaller than I thought it was going to be. 15.13, something like that. So I'll swap over to a mic and just creep it down to 15 mil. I'll be trying the bearing on there when I get to sort of 15.02, that sort of idea. But I'll get there. Well, I found the fit I'm looking for. There's absolutely no movement in there, and yet I can get it jammed. Okay, that be the fit. So I think I'll go around now and chamfer leading edge of that, inner edge of that, outer edge of that, and I think that's the turning part of this bit done. That was close. I nearly took it out of the chuck. I'm going to put an M5 up through the middle of here, probably, I don't know, 12 mil, something like that. Drill and tap it 12 mil deep. To take a retaining plate that's going to hold it into the bearing. So, yeah, I'm just going to drill and tap that for an M5. So what I'm going to do now is make a little keep plate. Now, as you know, I made that shoulder 11 mil, the bearing's 13, so I'm going to make a keep plate, like a little top hat that fits on the outside of here, with a 1 mil bit that sticks into the bore, and then a 5 mil hole through it, and if I put an M5 bolt, it'll tie the two together and hold that bearing solidly onto the upper part. The bearing, I don't know if I mentioned it before, is going to be Loctited into the aluminium support. Ideal world, I would have put a circlip in it, holding it down in the groove, but I haven't got any circlips. And yeah, I mean, the Loctite I've got, it's the good stuff. It's not going to come out, it's not going to move. I will, because I haven't got any countersunk screws, have to put a little hole in the base plate to relieve the head of the little cap head screw that I'm going to use to clamp it together. But that'll mean that it's accessible from below. Well, here we are, guys. That's the end of part 3 of making the ball turning attachment, shall we call it. Don't forget to check out Everett's workshop. And once again, guys, thank you so much for subscribing, hitting the like button, and for all your support. Cheers now.